Hello class, Assalamu alaikum wa rahmatullah. Good evening, good afternoon, good morning, good evening, good afternoon. It depends from where you are joining the program. I know we have students from across the globe. We'll come to the last and final session of this week, and this is my fourth session. And in this week we are learning the basic foundation of NLP, natural language processing. Unfortunately, these 4 sessions are not enough to grasp the big picture and dive deep into details, because this is just NLP itself by itself is 15 to 20 weeks training program. But I will do my best to give you some notions, and you could start on your own. So as data scientist, you are going to be dealing with data of different type, different structure, different format, and different size. You have to be prepared of dealing with the data regardless of the structure, regardless of the type, regardless of the shape, regardless of the size. And the data, the type of the data that we are learning to deal with this week is the unstructured data, and specifically the text data. So to extract information of a text data, the very first thing that we have to do systematically is number one is tokenize this data, or transform this data or split this data into the smallest unit called tokens. And there are 2 types of tokenization: sentence tokenization and word tokenization. Then after we tokenize them, then we need to remove any unneeded, unwanted, unnecessarily tokens. And we are talking here removing unimportant things like punctuations. You are going to see a lot of punctuation within a text, but these punctuations wouldn't add necessarily any value to your analysis. So we need to remove punctuations, we need to remove special characters, we need to remove the numbers or convert numbers into digits, and we need to remove stop words. Stop words is the most common words. A word like the, where, how many, what, for, and a. These are the stop words that wouldn't help you necessarily to grasp the meaning, or to grasp they wouldn't have any analytics value. And they believe in English there are around I'm not sure yet, it's around 193 stop words, around this, plus minus. So once we remove the stop words, we remove all the unnecessarily or unwanted tokens, then we need to stem and lemmatize. Stemming and lemmatization is a process that we use in NLP to keep the root of a word called the stem. Stem is the root of a word, by removing suffixes and prefixes and keep only the word, the roots. And there are 2 processes to do that. Stemming is one of them, and lemmatization is a second. Either one works, but both of them, they have pros and cons. Stemming, for example, is fast, but it has a drawback of spelling. It does not consider the meaning of a word. And lemmatization, it does use morphological analysis within its process. And this lemmatization, it's more accurate than stemming, but it takes time because of it does compare the final word with an existing online dictionary for and it does use an algorithm to find the nearest word from the dictionary to the word that you have, the final words. That's why it takes time. It's very slow, but it's more accurate. Then after that, we need to tag our remaining words, and then we need to stop there, getting the information we are looking for, or convert the remaining words into vector, so we can use an artificial intelligence. if you are planning to use artificial intelligence, you have to have the final documents converted into a vector. Vector means rows and columns. And yes, so yesterday we started the Jupyter notebook. We started this Jupyter notebook, simply trying to practice a little bit some of these processes. Then we are gonna learn how to split the data into units, into smallest units called tokenization. Then we are gonna hopefully learn. Yeah, we are gonna learn. Give me 1 second. See what we have. So we are gonna learn type of tokenization. We are gonna learn stemming, how to stem. We are gonna learn lemmatization. We are gonna learn how to remove stop words, and we are gonna then we are going to transform our data, the remaining data, into bag of words, transform it into vector using bag of words or TF-IDF. And finally, we'll try, if we have time, we'll try to find some similarities between documents. You have one document and two documents, or you have two books, and you want to find, you have two books, the same author, for example, but different versions. You want to look into these two books and find out within a click. You want to find what is the difference between version 1 and version 2. You could do that using the same process. So yesterday, yesterday we started. Let me zoom out a little bit so we make it clear. So hopefully now you will be able to see. Okay, so I'm going to start over. So I'm going to go to kernel, clear, restart. Beautiful. Unfortunately, we won't have time today to teach you a Jupyter notebook if you are doing this, if you are using this for the first time. But we have, hopefully you will be able to learn Jupyter notebook for the 4th week of this program. So anyhow, without assuming that you have some knowledge about Jupyter notebook, so we are going to import some libraries. These are libraries already installed in my system. I'm going to bring them to the memory, import regular expression. Then I'm going to create a function. That function, it takes one variable and it applies to the one variable the regular expression method to remove anything that is not string, and it splits the entire documents into smallest units and navigate through each unit at a time and remove it if it's not a string. So this is all what this function does. So create the function, and we are going to use, going forward, we are going to use clean text function. Clean text function, what it does, it takes a parameter, it takes an input, which is in our case the entire paragraph, and this is going to search, and this is going to split it into one unit, second unit, or third token, or 4 token, etc. And this is going to look through every single token, looking for all this, looking for anything that is not a string and remove them. So yesterday we created a variable, and of course we copied paste these documents from the Yahoo. So let's create the variable, and now we are going to look into we are going to do either print variable, print our variable, or simply the variable name. So here we go. So it prints out variable. So it's Baltimore, Cambridge. And if you look into this data, you got some special character in, the punctuation. You got a number in there. You got an apostrophe, and of course we got a lot of tokens that wouldn't bring any value. These are what we call the stop words. Updated ED should be removed. 5 for is a number. This is a number, should be removed. 19 should be removed. The should be removed. N, the, these all stop words that we need to remove from any text to be able to keep only the most important tokens or unit of the document. Okay, so now we are going to apply, we already created a function that is called, going up, sorry. So we already created the function that is called clean text. And clean text, it takes one variable. So we are going to apply this clean text to this variable. So this clean text will take one variable. Our variable now is going to be Yahoo. And in Yahoo, we have a paragraph, we have an article with many paragraphs. So now we are going to apply that clean text. Here we go. Yes, so we're creating a new variable called Yahoo2, and the value or the content of Yahoo2 is the content of Yahoo, but we apply the clean text to it. So the clean text is a function we created earlier using a regular expression that looks for into this document, looks for anything that is not string. Okay, we apply, voila. Now we got all tokens, and still we are not taking the stop words. We are not taking we are keeping them, because this clean text only looks for special characters, punctuations, and so we are not taking not taking numbers, and we are not doing any stemming, any lemmatization, and also we are not taking stop words. Okay, here is another sentence, very small sentence. Okay, this is our sentence, and we are going to apply clean text to the same sentence and see what we have. So this is the original sentence, and this is the clean sentence. So this is what we have now. It's all tokens, but we still need to do a lot of work removing stop words, removing the punctuation. So let me give you another example. Why do we need let's go to Yahoo, and we are going to take a very small paragraph, the same paragraph, let's say that we are going to look into just the smallest paragraph. So let's assume that we want to analyze this paragraph using automation or using artificial intelligence. So to analyze this paragraph, it can be analyzed, and whatever we can apply to one paragraph could be applied to thousands of books. So the very first thing we gotta do is we need to remove, as I said, punctuation. So we got one here. We got one. We got one here. Okay, we got some punctuations in there, and we have also we need to remove stop words. Stop words is the most common words like the, of, who, when, Scott Bridge, and this, on, said, and 8 worker were on, the, when, a. Okay, one of the, a, to, and, to the, to is not a stop word. Of the, and. So these are the stop words, and of course when we remove them there is going to be a space, so we need to remove stop words and white spaces, and also we need to lemmatize. So bodies, we want only we are going to remove IES. Killed is going to be killed. Scott K. Bridge. Collapse is going to be collapse. Earlier, early. Police said is going to be say. Authorities said is going to be say. worker, bridge, fixing is going to be fix, problem is going to be problem, flag is going to be flag, call, etc. So this is what we call the pre-processing. So we are going to remove a lot of words that wouldn't bring any value to the analysis. And finally, we need to convert this into tabular data, into rows and columns. And using bag of word and using the one-hot encoding, using TF-IDF, or using the word embedding methodologies, deep learning methodologies. Okay, we'll end up having just few words. So that is the process of dealing with NLP. Okay, so going back to our Jupyter notebook. Of course, I'm not going to go through this. I'm going to simply get into the most common, the best, or to the most important. So let's talk about the type of tokenizer. There are 5 types: white space tokenizer, tweet tokenizer, MWE tokenizer, regular expression tokenizer, and the word panged tokenizer. These are some different type of tokenizers. All what these tokenization methods are doing is splitting the entire sentence to the tokens, to the smallest units, and they act different. Okay, so to use this tokenizer, we are going to go to the library NLTK. There's NLTK library that's already been built, so we don't have to invent the wheel. It's already available, and now we import this NLTK. This is the library, and I'm going to share this the link with you on the chat, just for your reference later. So this is the library we are going to use. Okay, and this library, it is really one of the best libraries you could get. Of course, there are others, but this is so far my favorite library for natural language processing. So we are going to import from this library. We are going to import all the 5 tokenizer. So import from NLTK tokenize, import tweets tokenizer, MWE tokenizer, regular expression tokenizer, white space tokenizer, and word panged tokenizer. We are going to import them. Hopefully I have the library installed. Beautiful. Okay, if you don't have the library installed, all what you need to do is we are going to do pip install NLTK install and run, and the system is going to take you through a process if you don't have it. If you run this, once you have access to the code, when you run this, if you don't have NLTK, it's not going to run. You are going to get some errors. All what you need to do is install the library and run it again, and you should be good to go. Okay, so now we got a sentence. We got one sentence. The sentence that we have here is, I love to learn NLP in 2024. Thank you, InnovatiCS, for offering this training program for free. I know this program is of I know this program is over. Ramadan Kareem, we are going to do here. Ramadan Kareem, can you please offer it again? This is a sentence. Love to learn. So all I'm doing here, I created a variable called sentence. You could call it whatever you want. Store in that variable a sentence data. So this is data in terms of string sentence. So we got love to learn NLP in 2024. Thank you, InnovatiCS, for offering this training program for free. Ramadan Kareem. Can you please offer it again? Okay, so now we can apply, we can use the variable and apply many generic functions. Like the len function will calculate the length of this. So this one sentence has 144 characters, including punctuations and including the space. So for example, love, this is 1, O is 2, 3, 4, and the space is 5, 2, 6, 7, space, etc. So you got 144 elements or characters, including the space and punctuations for this one sentence. So now we are going to use tokenization to split this data, this one sentence, into the smallest unit. And we want to compare the 5 types of tokenization. You don't have to use in a real life scenario. You don't have, you use only one. Which one? Honestly, it's hard to make that decision. I know this, and then for example, if you are working on tweets, you could probably use the tweet tokenizer because it's designed around tweets. So if you are working with a document that has a lot of punctuation, probably you could do the word punct tokenizer. I don't really understand the true difference, to be honest with you, but in the real life scenario you could use one of them, and they know they have specific pros and cons. They have pros and cons, I know it for sure, but which one to use, it's totally up to you. But if you are working on a project, in a sensitive project or a project related to humans, I really think that you should take every possible cautious before you make a decision. Because if you are working on a project that are related to humans, and if you make a very teeny small teeny mistake or an error, you could kill someone, you could disable someone, you could impact someone's life. Okay, so now what we gotta do is we are gonna create functions around these tweets. This tokenizer. So we are gonna create a function called tokenize with tweet tokenizer. This is the name of the function. This function takes one parameter, one value. Then this value we are going to apply to it the tweet tokenizer that we already installed, that we don't import it, and we are going to print it out. So we are going to return the same sentence, and we are going to do the same for MWE. We create a function. Then we are going to do the same for regular expression. We name the regular expression tokenize with regular tokenizer. It takes one parameter. We apply the method to that one parameter. We return the parameter. We return the input. And the same thing we are going to do for white space. We create a function with the name white space. We take one parameter. We apply the white space tokenizer. We return that parameter. And we do the same for all these parameters. So I'm going to create the function, and I'm going to apply the function to the sentence, to this sentence. Okay, beautiful. And I'm creating another function, tokenize with MWE. Then we apply it to the same sentence. And now, here we go. And we'll go through this one more time. Then I'm creating a third function, regular expression, using the regular expression tokenizer. Apply it to the sentence. Then I'm creating a fourth function, it's white space tokenizer. apply it to the sentence, then creating the fifth tokenizer, which is a word peng tokenizer, creating the function, apply it to the sentence, and now let's compare. We are going to compare the length of the 5 tokenization, and we know that we have 144 called 144 characters, including the space of the entire sentence. And let's see, this is the tokenizer we tweet. So love to learn NLP. You see the punctuation is a token. We got free, we got exclamation mark, exclamation mark, exclamation mark, and the punctuation. All these punctuation, they are unique. They are single. We call them token. And you got the smiling face is a token as well. For the MWE tokenizer, it considers free, exclamation, exclamation, and the dot as one token. Okay, so it's not considering, as you see, the punctuation is a part of tokenizer, so that is totally different behavior than the previous tweet tokenizer. It's the different behavior. So now let's compare them in terms of the length. So give me the length of the first tokenizer. It has 31. The second one 25. Third one 28. 25 and 28. So out of this 144, this is the length of the function. Out of 144 character of the sentence, including the punctuations and the spaces, the tweet tokenizer only found 31 tokens. The MWE tokenizer 25 tokens, and for regular expression 28, 25, and 28 for word peng. Which one is best? I really don't know. But at the end of the day, you try only one. You try only one, or you use only one. You cannot use all of them. One should be enough. Of course, as I mentioned earlier, unless you are working on a sensitive project, means a project that is related to humans, you need to be very careful of the choice of the methods, pre-processing methods, because a very small, teeny, unintentional wrong process would provide wrong information, and with the wrong information you could mislead the decision makers. And of course, making a choice in humans using wrong information could impact badly someone's life. Okay, so any question, any concern, please? Any question, any concern, any doubt about tokenization? Yes, Adil?
Assalamu alaikum. The length of the tokenization represents the punctuation and the space that was removed or the result of the function.
Yeah, these are the number of tokens that were extracted using a different tokenizer system.
Okay.
So for the sentence, so we got this sentence here. Let's go back to the sentence. This is our sentence.
Yeah.
Now this is our sentence. And when we try to tokenize it, this is what we are going to get. So this is one token. This is the second one, third, fourth, fifth, sixth, etc. So this space is not included. There's no space in there. So we are going to get love, one token, two is another. We are going to get learn, then NLP, etc. So counting how many tokens that we have, some of these tokens are found at 31, some of them 25 tokens, some of them 28. Which one is good? I don't know yet. Why there is a difference? Because some of these tokens consider tokenization, consider this as one word. This is one word. Some of them say no, free is a token, exclamation mark is a token, exclamation mark is a token, the third one is a token, and the full stop is a token. So you got 1, 2, 3, 4, 5. You got 5. Someone consider it as one. Some tokens consider it the entire word as one.
Okay. So it doesn't remove them. It just
right now we just split them.
Okay.
Then,
Thank you.
Then when we will be using the stop words removal, we are going to go through the first one. Are you stop word? No, keep it. Are you stop word? Yes, bye-bye. Are you stop word? No, keep it. Are you stop word? No, keep it. Are you stop word? Yes, bye-bye. Are you a number? Yes, bye-bye. Are you punctuation? Yes. Then we will end up, this is what we will end up having. We are going to have love, learn, NLP, thank, InnovatiCS, offering, training, program, free, Ramadan, Kareem, offer. Again.
Okay.
So these are the remaining word, the most common remaining words that we can analyze further. Everything else, you're welcome. Everything else is a garbage. This is garbage. All of these, they are for and for again. Can you maybe please? And the smile. This is a garbage. Okay, and this is only one sentence. What if you have a book with 500 pages and every page has 1,000 of words in it? So the same applies. We are going to remove, we are going to split into units, and we are going to navigate through we are going to split into tokens, and systematically we are going to navigate, we are going to look through every single token to determine if it should be kept or it should be removed. It should be kept if it's not a punctuation, if it's not a stop word, if it's not a special character, or if it's not a number, or if it's not a white space. If it's not none of these categories, we keep it. If it's among any of these categories, we remove it. We got here offering. Now we got offering. We need to remove ing. Okay, training, we need to remove ing. So because now for the system, offering and offer, they are two distinct, two unique words. Offering and offer. They are two, one and two. But in reality, it's only one. You agree? Adil?
Yes, I agree.
Now
because they have the same root.
Yeah, so now we need to apply stemming or lemmatization to remove the prefixes and suffixes, to keep only the word, to keep only the root of a word. That is what we call stemming or lemmatization. Okay?
Okay.
Other questions? Khalid? Khalid, go ahead. Shahzad?
Brother, can you hear me?
Yes, sir.
Yes. So my question I have, trying to understand after this all tokenization and lemmatization and stemming. So as an example from this sentence, what are we going to get out of this one? So what will be our net result? What is the benefit we are going to see? That's what I'm trying to understand.
Sure, very good question. So let's go back to the same sentence. Let's say that. I'll give you one example. Let's say that this is a review. Okay, this is a review that you got online.
Okay.
You don't know if it's positive or negative, right? And let's say that you have let's say 100 reviews. You want to see what your audience are talking about the services you are providing, and you don't have time to go through every single review. You don't have time to do that, right?
Right.
So, yeah, we need to design a system that can look into these reviews and determine if it's a positive or negative. This is simply one example. So to do that, number one, we need to pre-process all our reviews all the way to 10,000 to 1,000. We need to pre-process them. How do we pre-process them? Number one, we need to tokenize them. Once we tokenize them, then we need to remove from all of these 1,000, we need to remove the stop words, spaces, because these wouldn't add any value to the analysis. You are not going to learn. The system is not going to learn. Okay? And after that, we need to lematize them. Remove, keeping only the root. Okay? Then we need to transform the entire 1,000 documents into tabular data. Okay, we are going to go something like this.
Sure.
We are going to get review 1, review 2, review 3, review 1,000. And we got word 1, word 2, word 3, word 4, then up to the length of the unique words. And we got some numbers. Okay, then we are going to go through this 1,000 manually, and we are going to label them. So what do you think about the first sentence? Is it positive or negative?
Overall, positive to negative.
No, just the first one. This is the first one, brother. Is it positive
The
or negative?
first one is positive.
Positive. So we are going to do positive. We are going to go to the second one is positive. We are going to go to the third one is negative. Fourth is positive all the way to the end. Okay? Now we are going to use artificial intelligence to find the mathematical behavior between the words and the label. And tomorrow, if you give me 100 new reviews, I can label them within one click if they were positive or negative, and you will have all the information in front of you, so you can make a decision right in the fly. So this is one example of how we can use NLP, the processing, the tokenization, to get into designing a systematic or a system that check or detect if your audience are talking bad or good about yourself or about your services right on the fly, and make a decision right on the fly. Imagine that you are welcome. Imagine that you have a restaurant. You are the owner of a restaurant, and you are serving a lot of people. Okay, and of course people, they talk about this is a beautiful place, this is a bad place, you know, the food is salty, the food is this and that, and you got this system that, you know, that checks or that pulls this feedback or the reviews from your social media and analyze it right on the fly. And someone just said, you know, you got 10, no, you got, for example, you got 100 visitors today. Now they are still on table. Someone or 10 of them, they said this is a salty meal. What you are gonna do? Of course, you don't have time even to read those reviews, but with a system already in place, they're already been trained. We already trained the system on some reviews that we labeled as positive or negative. We train, we learn the pattern, and we can apply this pattern on this 100 visitors that you have today, and they are socially and they are posting on the social media. You can determine right on the fly what they are saying, and you can correct anything that should be corrected or apologize to them right on the fly before the word spread about your bad service. And you will stay in the business. Otherwise, no one next day, no one is going to come to your restaurant. This is the power of applying NLP to remain in the business. And to do that, you have to go through a process. So you got the reviews. First of all, we need to pre-process them before to learn. Why do we need to do this? Because we want to learn the hidden mathematical relationships between all these reviews and their label. And whatever we learn mathematically, which we don't care, the system knows it, the algorithm knows it, we are going to apply it into new or coming up, any new coming up reviews. The moment someone posts something, you got a flag that is positive or negative. It's a positive, you let it go. If it's negative, you got to correct what has been. Maybe talk to the client, apologize, offer them a free meal, do something, because one client could ruin the entire business. And in Moroccan Arabic we say حوتة وحدة تخنز شوارب ديال الحوت. I don't know the explanation in English, but I think we have something in English similar to this. Okay?
Okay. Thank you.
You're welcome. Other questions, please? Other questions? Okay. So let's proceed. Now we just token this sentence, and now we need to lematize it. Yeah, we need to lematize. Means we need to remove prefixes and suffixes from the words, from the tokens. We need to remove punctuations. We need to remove white space. Let's do that very quick. So stemming, there are a lot of stemmers, and one of them regular expressions. So from the same library, we are going to import a stemmer. It's called regular expression stemmer. We got the same sentence. Let's take the same sentence, exactly the same sentence. And let's stem it. Let's see what this stemmer is going to do. So we got the sentence. Here we go. I love to learn NLP in 2024. Thank you, InnovatiCS, for offering this training program for free. Ramadan Kareem, can you please offer it again? And inshallah, yes, we can offer it again. And as a matter of fact, I can offer you a free 15 weeks NLP program and LLMs, large language models. I simply don't know when, but I don't have a problem starting a free program. It's going to be once a week for 4 hours every week. So around maybe 60 hours learning NLP and large language models from zero, from nowhere. So we create a function again called get stems, and we import we initiated the action. So we are going to apply a regular expression which we imported, and this regular expression takes applies two things. It looks for, it is going to remove anything that is ing, and of course the minimum words that we have is 4, and we return. So once we apply the stemmer, we are going to join the words, the stemmed words. We are going to split, apply the regular expression, and join back. Okay, now we are going to apply this on the sentence. Okay, and what is this? Regular expression not defined. What do you know? Get stem. Yes, it was defined. So I'm getting this error. Regular expression is not defined because I did not run. You see the brackets, nothing in there. So now let's run, import the regular expression into the memory, create the sentence, create a function to stem the sentence, print the sentence, and compare it to the stem sentence. So this is our sentence. Love to learn NLP in 2024. Thank you, InnovatiCS, for offering. Love to learn NLP in 2024. Thank you, InnovatiCS, for offer. So ing is gone. Training, train. Now the ing is gone. Program. And now how many offer we have? In the first sentence, we got 1 offer. 1 offer. In the second sentence, we got 1 and 2. We got 2 offers. So this is simply an example of how we can use the regular expression. In regular expression, we got to define we got to define manually what to remove. There are some stemmers, like porter stemmer, automatically it is gonna remove. You see, you don't specify anything. By default, it is going to remove any prefixes and suffixes of a word, and it keeps only the root of a word. So let's import the stem porter, create a function, define the function, give it a name and the parameters, initiate your function, and the action is we are going to split. Split means is another word of tokenizing. So we are going to tokenize the entire input. Then we are going to look into every token, and any token that has prefixes or suffixes, we are going to stem them, and finally we are going to join the entire sentence together. We are going to split. When we split, you are going to see a list of words. You are going to see something like this. Then we are going to navigate through every single word or every single token one at a time, and when we are done, we need to join back all the remaining words into a sentence. So we create the function, and we import the function, we create a function. This is our the sentence, original sentence, and this is the stem sentence. Love to learn NLP. Thank you, Innova. You see it moves. This is the problem with stemming. Stemming, it's fast, but you are gonna have to deal with a lot of misspelling. So we got InnovatiCS, but it reads it. It thought that it thought this is a prefix for offering, offer. This, it moves an S. Train, training, yes. Program for free. Ramadan Kareem, can you please? It removes an E. Offer it again. So yes, it worked, but unfortunately, it created a lot of misspelling words. Yes, capital were changed. Yes, it does, and take care of the capital. Yes. Okay, so we are going to do one example of lemmatization, which is similar to stemming. Stemming and lemmatization, there are two processes used in NLP to keep only the stem or keep only the word. Unfortunately, I have to remove you. Okay, bye-bye. Okay. So, as I said, stemming and lemmatization, they are doing the same job, except, as I said earlier, the stemming is fast, and also it does create a problem with spelling. And for the lemmatization is more accurate, but it's very slow, because it's not only looking for this, it's not only analyzing the token at this syntactical level, but the semantic level also. It's using morphological analysis to do the job. So this NLTK, again, we are going to import WordNet Lemmatizer. So once this function applies the stemming or find the root of a word, it compares it with a dictionary, an online dictionary called WordNet. So WordNet is a dictionary of all correct English WordNet. Yeah, all correct dictionaries, all the correct words. I don't know about the list. Use WordNet. Anyhow, so yeah, I think this is Brighton University WordNet lexical database. Yeah, lexical database for English. So it has all of the English words, correct spelled English words. So when it does splitting, when it looks for the root of a word, and for example, if let's an example, if it has a word like this one, so we know it's this, but an S was removed. So what it does, this lemmatization, it looks for the WordNet dictionary for the nearest word to THI. What is the nearest word? And of course, an algorithm would be applied, most likely K nearest neighbor, if I'm not wrong, that calculates the distance or calculates the similarity of the word that we're trying to look up with the word in the dictionary. That is why it's slow, and it is going to correct it. It's going to bring the closest word to THI, which is this. So it's going to add an S using the comparison to the WordNet dictionary. That is why it's slow. This lemmatization is very slow, especially if you are working on a huge amount of data and your computation system or system is struggling with computation, slowness and memory. This word lemmatization might not be the option for that scenario. So we are going to do import WordNet Lemmatizer from NLTK, and we are going to import the WordNet dictionary also. So we are going to download the function and the dictionary. Okay, so everything is installed. Now let's look into the sentence again. So this is our sentence. Love to learn NLP in 2024. Thank you, InnovatiCS, all the way to the end. So we are going to import, we are going to create a function, and this function, it takes one parameter, and we are using a Lemmatizer, which is WordNet Lemmatizer, to lemmatize the given text. And so number one, it is going to split it into word tokenizer. So WordNet Lemmatizer is a tokenizer and a stemmer at the same time. So it is going to tokenize the entire sentence then it's going to apply the lemmatize. Lemmatize is going to look for the root. It's going to correct the any error or any misspelling, and finally it is going to join. It's going to join the entire sentence back. So we create a function. It's called get lemmas, and now we are going to apply the get lemmas into the sentence. We are going to apply the get lemmas into this sentence, and let's take a look. Love to learn. You see, it did. It's the same, but it's actually removed IC, offering, training, and it put them back because it find out this is the best or the best words that we can use. Stop words, and I think we are going to stop here. Unfortunately, I will be more than happy to give you more extra hours, but after the program, on finishing this Jupyter notebook, we are doing we'll be applying the stop words. Then we have feature extraction. Then finally we are going to do the vectorization. So we are going to do vectorization, and that should be it. Okay, folks. Yeah, I'm going to stop here and open the floor to see if you have any question, any doubt, any concern. Yeah, please raise your hand if you, and ask for Mike if you have any question, any concern, any doubt. Yes, Bulan, Malik?
Yeah, thank you, brother. So my question is on this lemmatization. What exactly it did? Because we just basically added some spaces, it seems like, but the words actually just remains similar, right?
Yeah, for this one sentence, unfortunately it did not do anything, but in reality, it is going to remove all the prefixes and suffixes. It is going to convert the verbs, the conjugated verbs into original. Like for example, if you have something called has been or was, it is going to be to be or is. So it doesn't work, but for reason it's not doing it for this one sentence because it's only one sentence.
Okay, got it. Thank you.
You're welcome. Okay, folks, so my apologies if I didn't do a good job explaining the concept of NLP starting from session number 1 up to today. My sincerest apologies for that. Inshallah, we can meet with you guys anytime soon. So next week, we are going to have 4 sessions, and it is going to be on artificial intelligence, on cloud computing. So it is going to be an introduction to cloud computing. So please try, put an effort to join this, learn, and reach out to me in case you need help with anything. And please, if you need help with any future things, my recommendation is to connect with me through my LinkedIn. And here is, take a screenshot or connect with me through LinkedIn, and I will be more than happy to support you outside the program. If you are working on a project, if you need a resume preparation, if you need interview preparation, if you need help with the course, with the project you are working on, either if it's academic project or industry project, I will be more than happy to assist you, and it's free of charge, inshallah. Okay, Bulan, Malik?
Yes, so just to clarify, this program runs only during the weekdays, right? So
yes,
no
Saturdays.
Saturdays.
Yes, Monday through Friday.
Thank you.
Okay, brothers and sisters.
Monday to Thursday, right?
Go ahead, Khalid.
Yeah. Is it possible that we can given any link or something just where we can because I just want to understand further this concept of the limit. I don't know how to pronounce. But if there is any further examples, any links or something, it can help in this.
Yes, ma'am. Text me on WhatsApp. I'll provide some documents, inshallah.
Okay, no worries. Thank you.
Is it till Friday or Monday till Thursday?
Is Monday through Thursday.
Yes. Thank you.
Okay, so 4 days a week. Okay, one last person, Hisham. Hisham,
Yeah.
you have?
First, thank you for your information and your efforts and this valuable information you give us from your time. My question is gonna be like afternoon, like today, like 5 o'clock, or it's gonna be, from Monday to Thursday, right?
Yeah, it is going to be the same time from 5 p.m. Eastern Time to 6 p.m. Eastern Time.
Yeah, the reason I asked because my work schedule is switched, that's why I want to make sure. So please, anyway, we can reach out to this information, or it can be recorded somewhere.
It's all going to be recorded and uploaded to Canvas. If you don't have access to Canvas, please reach out to me. I will be more than happy to troubleshoot your account. If you register, you should get an invite from us to access to Canvas.
Okay, so you should register to Canvas. Is that online?
No, register.
All right, sounds good.
No, register through the link that we shared with you on WhatsApp, and once we have your registration, we are going to invite you to join the Canvas.
Okay, thank you very much, brother. Appreciate your help. Thank you.
Okay, شباب اللي في المغرب اللي they don't speak English شي سؤال شي استفسار حتى بالعربية ما عندي مشكل. الشباب اللي في المغرب كاين شي تساؤل؟ جواد؟
Sir, I didn't understand well the example of lemmatization. That's the last one.
Yeah, unfortunately, we gotta stop here.
I don't know what the library changed in the sentences.
Yeah, okay, Jawad, you might need to schedule another one-to-one session with me, and I will be more than happy to explain it with more details.
Okay, sir.
Okay, unfortunately, to explain it, we are going to need another 10 to 15 minutes, and we have to stop by 6. Okay, folks, that's it.
Please add me as well. Add me in the, when you have the session, please add me as well.
Sure, we'll do that. Please, just share your concern on the WhatsApp group, and connect with me on the LinkedIn if you need any help. I will be more than happy to assist you further, inshallah. Okay, folks, Ramadan Kareem to you all. It was a pleasure having you in these 4 sessions. I know they are very short, but inshallah, you should be able now to at least have a better understanding of how to deal with textual data. Should be a jump start. This is not the end, this is the beginning. So please put effort in learning data science and artificial intelligence, regardless of how much it's going to take you and how much it's going to cost you. And inshallah ta'ala, hope to see you one day as superhero data scientist. Until then, you guys have a great evening. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Ila liqa, bye bye.